Hi, this video is from 2000, a question from 2021 AP AB exam, question number 3. It's a non-calculator question. So, company designs spinning toys using a family of functions that's given there. C is a positive value, and what we need to do, so it shows us the first quadrant bounded by the x-axis, so some value of c, all they are going to look the same. I do want to notice right away that if you set 4 minus x squared equals 0, you're going to get x equals plus or minus 2, so this value here is going to be 2. So all these will have boundaries from 0 to 2 regardless of the value of c. Okay, and each spinning toy is going to be obtained by revolving that about the x-axis, and x and y are measured in inches. So the first question is find the area of the region. So to find the area of this region, we're going to do the integral from 0 to 2. It says the value of c is 6, so it's going to be 6x square root of 4 minus x squared dx. Now we do need to integrate that using u substitution. So we're going to say 4 minus x squared is u, which after we take care of that is going to be x dx equals negative 1/2 du. And then from here we can make substitution. So our area is going to be negative 3, because 6 times negative 1/2 is negative 3. It's going to be the integral from, when we substitute the values of x equals 0, we are going to get 4 for the value of y, and when we substitute 2 for the value of x, we are going to get 0 for the value of u. So it's going to be square root of u du. This is what we get now. So this is going to end up giving us negative 3. It's u to the power 1/2 here. So when you integrate that, you are going to get 2/3 times u to the power 3/2 from 4 to 0, and from here we can continue on. After doing all these computations, you are going to get 16. So that value is going to be 16. It doesn't ask for units, so we're just going to leave it like that. Okay, so that's part A. For part B, the question is, it is known that for the derivative of this function that we just worked with, y equals cx square root of x 4 minus x squared, is given to us. And the radius of the largest cross-sectional circular slice is going to be 1.2 inches. What's the value of c for that spinning toy? Well, if you look at the derivative, you want this derivative to be 0, since they're talking about the maximum value. So that means dy over dx equals 0, which essentially, if you look at the derivative, you want the numerator to equal 0. So right here, and the only thing that can be 0 there is 4 minus 2x squared. So that means that 4 minus 2x squared equals 0, which means x is going to be, it's actually going to be plus or minus square root of 2, but the only reasonable answer here is going to be square root of 2. Okay, so what do we want now to happen? We want the derivative, the derivative is going to be 0 at this point, and we want this function, our function y, to equal to that value. So it's y equals c times x times square root of 4 minus x squared. So we know that the slice, the radius of the slice is 1.2, so y is 1.2, c times square root of 2 times square root of 4 minus 2, and that's going to give us 1.2 equals 2c, so c is going to be 0.6. That's the value of c. Okay, and the last question here is, for another spinning toy, the volume is 2 pi cubic inches. Find the value of c for that spinning toy. So we need to set up the volume expression. So we know that the volume is going to be 2 pi. It's a volume of a solid revolution. It's going to be the integral from 0 to 2. We're going to square our function. Okay. And we know this volume is going to be 2 pi. So 2 pi equals 2 pi times the integral from 0 to 2 of c squared x squared 4 minus x squared dx. And we're going to go ahead and proceed with integration here. So we can divide both sides by 2 pi. And then we're going to get 1 equals, we can factor out c squared, I'm sorry, not factor it out, but take it out of the integral sign because it's a constant. And we're going to get the integral from 0 to 2. And here we're going to have 4x squared minus x to the 4th dx. Okay. So continuing with this, we can see that 1, if we do add both sides by c squared, 1 over c squared, here we're going to get 4x cubed over 3 minus x to the 5th over 5, all that going from 0 to 2. So 1 over c squared equals, it's going to be 32 over 3 minus 32 over 5. So 1 over c squared equals, it's going to give us 64 over 15. So c squared equals 15 over 64. And c is going to be square root of 15 over 8. We only use positive values, so that is all we're going to need. Okay, so that's this problem.